Have you ever just stood at the bottom of a skyscraper, looked all the way up and wondered, what is actually holding all of this together? It's not just the giant beams and columns that we can see. Turns out, the real secret is often hidden in the smallest, most important little pieces.
Okay, so let's just dive right in. I mean, really, how do these enormous structures that we live and work in every day, how do they manage to defy gravity, fight off the wind, and just handle everything the world throws at them?
Well, the truth is, they're in a constant silent war. Every single second, they are being attacked by all these powerful invisible forces that are trying to push them, pull them, and basically twist them apart. So let's start by getting to know the enemy, right? What exactly are these invisible forces our buildings are always up against?
This really breaks it down. You've got these huge wind loads trying to shove the building over. Then there's the violent shaking from earthquakes, seismic activity. And of course, there's the nonstop crushing pull of gravity on the building's own massive weight. Even things like temperature changes can cause pressure as materials expand and contract. It's a relentless battle.
So how do buildings fight back? Well, their defense often relies on these small but incredibly mighty unsung heroes. And today, we're going to focus on a really important one, the SHS bracing cleat. Now, SHS just stands for Structural Hollow Section. It's a super common type of steel beam.
It might just look like a simple little piece of steel with some holes punched in it, but its job is absolutely critical. Think of it like a specialized joint in the building skeleton. It connects the diagonal braces to the main frame, and its entire reason for being is to take all those dangerous forces we were just talking about and channel them safely through the structure. And you know what? Once you know what these are, you realize they are everywhere. They're a key part of modern steel office buildings, those gigantic industrial warehouses and sheds you see on the side of the highway, and even in all the new modular and prefabricated buildings that are popping up.
But here's the real million-dollar question. How does an engineer know exactly which plate to use for which job? I mean, you can't just guess when people's safety is on the line. Well, that's where their secret weapon comes in. A kind of cheat sheet that makes designing these connections both ridiculously simple and incredibly safe.
And this just shows you what a huge leap forward we're talking about. The old way, well, every single one of these connections meant an engineer had to do a bunch of complex, super time-consuming calculations by hand. It was slow, and honestly, way more open to mistakes. The new way, a quick, instant lookup in what's called a design capacity table.
Let's actually take a peek at one of these tables. I know, it might just look like a grid of numbers, but for an engineer, this thing is pure gold. It lays out exactly how much force, which we measure in kilonewtons, a specific cleat with a specific thickness and bolt size is already proven to handle. And just so you know, 1 kilonewton is about the weight of a big person. So, here's the magic. Let's say an engineer figures out that a certain connection in a building needs to handle 90 kilonewtons of force. They just glance at the table, they find 90 kilonewtons, and boom, right there. They know instantly they need a 6mm thick cleat with M20 bolts. No guesswork, no complicated math, just pure data-driven safety.
Now let's zoom out for a second, because this system is about so much more than just making an engineer's job easier. It gives the entire construction industry 3 massive, game-changing benefits.
First and foremost, let's talk about what's at stake. Look at what these tables are designed to prevent. We are talking about catastrophic failures here. Bolts just shearing right off, the steel plate itself tearing like it's paper, and worst of all, something called a progressive collapse, where one tiny failure causes a disastrous domino effect.
So these simple-looking tables accomplish 3 crucial things. Number 1, they ensure structural safety, period. Number 2, they guarantee that the design follows all the strict national building codes and standards. And number 3, they let engineers make much faster decisions, which speeds up the whole construction process.
And this really gets us to the core idea of this whole explainer, this idea that a really small part can have a truly massive impact. The safety of our biggest buildings really depends on having total trust in the data behind its smallest parts. This is exactly why engineers and builders love this system. It gives them predictable performance they can count on every single time. It massively cuts down on design time. It makes getting the plans approved a much smoother process. That leads to faster construction out on the site, and maybe most importantly, it seriously lowers the risk of human error. It's a win on every single level.
You know, the source material we looked into for this summed it all up with this simple but really powerful phrase. The whole goal of all this data, all this engineering, is to give you strength you can design with confidence.
So the next time you look up at some towering building, just remember,
Its incredible strength doesn't just come from the giant beams you can imagine. It comes from thousands of tiny, perfectly engineered connections that you can't even see, each one chosen with absolute confidence, all thanks to a simple table of data, making sure that whole thing stands strong against every invisible force.